All right, guys, sorry that I had to be out today. There's nothing I could do about it. Make sure that if you owe me any homework or anything, you put it in the box. If you have to do a retest or make up a test that you weren't here for, I'm sorry I wasn't here today. We need to do it in the next couple of days, okay? We do have a quiz tomorrow on Tuesday where homework 7.1 and 7.2 will be due. The quiz is a pretty quick and easy one, so just real fast, I want to just go over a couple of things. There might be a question. You can't really see the dots all that well here. Let me just make them a little bit darker. There might be a question on there that just gives you a graph. It's all labeled and everything and says, draw the line of best fit and say if it's increase or positive correlation, negative correlation, or no correlation. So if I drew this one, I would sketch the line through it and I'd say that's a positive correlation because the slope is positive. Say it was the reverse and it looks something like this. I'd say it's a negative correlation, and I would draw the line like that. So not only make sure, we'll read the directions and it'll tell you, but make sure that you draw those correctly. Another one's probably going to give you a graph. Let me get rid of these. So they're going to give you a graph, and it's going to have data for you. So there's some points on here like this. Maybe they say down here we have year 1, 2, 3, 4, 5. And up here we have like, I don't know, weight, like 10, 20, 30, 40, something like this. And then they might ask you, well, if the trend continues at year 5, how high up will it be? Well, we'd want to kind of draw our line of best fit, and then we'd want to go from 5 and move up, okay? So it looks like this would be somewhere between 40 and 50. And remember, that is an estimation, okay? So make sure you do that. The last question will be what we do today. So I'm going to bring up my calculator here because we're going to be looking at a lot of tables. The table below shows the life expectancy of people born in the U.S. between 1900 and 1990. So it goes up in 10-year increments. We're going to find the linear equation for these data points, but on the calculator. So we're going to get out our calculator, guys. You really need to pay attention, okay? This is what we've done before with the stats. So everyone needs to, first, we have to turn diagnostics on, okay? So everyone hit second 0. It's going to bring up this sheet, this view. Push second 0, and we go down to diagnostics on. It's going to take me longer on my calculator. We should all be doing it. If you don't do this, you're going to miss out on that R value, and that's what we're actually going to use today. Sorry, I can't just scroll down and have to click every time. So I'm at diagnostics on, and I'm going to hit enter twice until it says done, okay? So everybody make sure we do that. If we need to pause the video to everybody to get there, then that's what we need to do. After that, go into stat, go into edit, just like we've been doing, and start entering your X values into L1. The year of birth is our X value, so 1900, enter. We've got 1910, we've got 1920, and so on. So make sure and enter those all in. Double check them because I think I entered this 1920 wrong. And do it for every one of them. Did it again. You got to be careful. I think it's because my thing's not calibrated, but whatever. All right, so once we get those entered in, you probably want to check through and make sure you're good. Then we'll move over to L2, and now we're going to enter in the life expectancy. So 47.3, 50.0, we can just put 50, 54.1, and so on. Now, if we need to pause this, everyone needs to make sure they have this in their calculator. If you can do this, this whole lesson and whole homework is going to be really easy. But it's really easy to mess one of these numbers up, so let's make sure we go back and check. You can leave off a decimal real easy, hit the wrong button. And 75.4. So I'm going to kind of go up. It looks like my columns are matched. I'm going to make sure I don't have like 629 in there. Now, once we do that, I'm going to move down in my table here a little bit. It says, remember to enter in your calculator, go to Stat Edit. The left column is R, the L2 column is Y. Now, we're going to put that, we have it in our calculator. We're going to go to Stat. We're going to go right to calculate. So everybody, we're in Stat, then right over to calculate, and we're going to do number 4, and we're going to hit enter. It should give us a lot of really crazy numbers this time. These equations, remember, when it's scatter plots, it's real life, they're not always going to be perfect, so there's a lot of really nasty numbers in here. So let's write those down real quick. So it tells me A is 0.32581818. I'm not going to write out any more of those. I think we know that's going to go on forever. B is a really big number, negative 570.5363. And then we have an R2 value that we don't care. Don't care. That's something for another time. But we do care about the R value, and that's 0.98303.11017. That's not the kind of R value we're used to seeing, okay? Now, we know from a previous lesson that if R equals 1 or negative 1, we have a linear equation. Well, in this case, we don't really have one, but it's really close, okay? It's really close to 1. So we're going to look at the next page. Make sure you have those written down. They should be in your calculator. So let's answer a couple of questions real quick. First, it says, is the data linear? And it's not. Let me scroll down a little bit more, sorry. Is the data linear? No, it isn't. The reason is because R is not equal to 1 or negative 1. It was really close, but it wasn't quite there. Now it says rounding to the nearest thousandth or 4 decimal places, the line of best fit is. This is where we plug in our numbers. So I'm going to write y equals. It gave us A. I'm going to round that to 0.3258. We put our x after it. Then minus that 570.5363. So this is not the equation that fits all our data. This is the equation of the line of best fit. When you're talking about line of best fit, R does not have to be 1 or negative 1. Now, the next thing I'm going to show you guys isn't really anything super important. If we're having trouble with it, that's totally fine. I'm going to have to get rid of this equation. If we need to pause or go back for everybody to write that down, go ahead. What we're going to do now is look at our scatter plot in our calculator, okay? It's slightly more complicated, but you don't really have to do this. So what you're going to do is you're going to hit second, and you're going to hit y equals. And you can see it has plot 1, plot 2, all that. We're going to go to plot 1 and hit enter. We're going to go down and see how it's got on and off is probably highlighted. Go down to where it's on, like it's blinking on mine, and hit enter. What that means is we're going to use our L1 and L2 to plot stuff, okay? It says down below that we have X list as our L1, Y list as our L2, and that's exactly what we want. Oops, sorry, wrong button here. Now, basically, that's all we have to do. It's nice and set up. We want our X list to be L1, our Y list to be L2. Now, if we hit the graph button, oops, sorry. So the graph we're showing right here, it's not big enough, so because obviously some of our numbers were in the 1900s. So I want you to hit the zoom button, and you can scroll down to 9 if you want to, or just push 9, but it's going to zoom in on the stat. That's the stuff we put in the stat menu. So I'm going to hit 9. There's our scatter plot, okay? So it's nothing real complicated. It's nothing that you have to do, but it does help you kind of see what your stuff looks like, okay? Now we're going to go forward just a little bit. We're going to use that equation we just found, just like we did Friday, to answer a couple of questions, okay? All these questions are going to be our predictions. They're not for sure. It's just our best guesses. So it says, what's the life expectancy of a person born in 1942? And it wants us to round to the nearest whole number, okay? So this is an X value, because when we look back at our table, it said year of birth was our X value. So I'm going to take my equation, and I'm going to plug in, it looks like 1942 for X. So I have Y equals 0.3258. That's the slope, essentially, times my X value, 1942, oops, not plus, minus 570.5363. Now, everyone needs to put that in their calculator. I mean, this is what you're going to have to do on your homework. When you do that, we want to round it to the nearest whole number, okay? So if we need to pause for a second to let everybody do that, we will. If you're waiting for other people, we have 2 more problems that are exactly the same. They're giving us an X value here and an X value there. So when I put it into my calculator, I got that if you were born in 1942, you should have lived about 62 years. Now, that's just an estimation, okay? Let's do the same thing with 1986. So I want to pause for just a second. You're basically going to have this times whatever your x value is. Be very careful when you're putting it in your calculator. So let's do both of those. So hopefully we've got some of this done, guys. I plugged in 1986 for x here and 2000 for x there. Now, we should know by looking at that calculator just a minute ago that this has got a positive correlation, so we should be going up. It should be over 62 years. So when I plug 1986 into my calculator, I got 76.5, but we got to round that to the nearest whole number, which is 77 years. So if you were born in 1986, you can expect to live 77 years. Now we put in 32,000, and see, I forgot my decimal there. You can't see. We've got to be careful. For this one, I got that people born in 2000 should live about 81 years. So this is exactly what we did Friday, guys. It's just the calculator's giving us a fraction. Maybe it's got some decimals in there, but big deal. If they gave you x values, you plug them in for x and use your table to know. Had they said what year was someone born in that lived, 84 years, then you'd plug that in for y and solve backwards, okay? So when it gives you these questions, look back at your table and decide, do they give me x values or y values? Let's go to the next page. And that's exactly what happens on the next one. Sorry, I forgot that was here. It says, what year was the person born in whose life expectancy was 67 years? That's a y value. So I'm going to plug that into my equation for y. So I get 67 equals 0.3258x minus 570.5363. Now it's got some decimals in here, but big deal, we can do that. First I'm going to add that number to both sides. We did not give you much room here. I'm running out already. Once I did that, 67 plus 570.5363 gave me 637.5363. And that's going to equal the 0.3258x. Of course, the last step will be to divide by 0.3258, which should give us a much bigger number. Now, we assume this is going to be somewhere in the 1900s. I got that this equaled 1957, rounding it to the whole number, that is, okay? So be careful, guys. All it's about is finding out what's x and what's y. The calculator does everything else for you. Now, let's look at another one here. It says the table shows the hours of TV watched by 10 students and their scores on a math quiz. So we're talking about hours watched TV and how well they scored on a quiz. The independent variable, of course, is always x, and in this case, x is the hours. The dependent variable is always y. In this case, it's the score we made on the quiz. Is this linear data? Well, to find that out, guys, we're going to have to put that in our calculator. So I'm going to have to get rid of those two answers. Let me bring up my calculator again. We're going to go back into stat edit, and we're going to start putting our values in. So in x, we've got 15. Well, let's go up and clear it first just in case. Go up to L1, see how L1 is highlighted? Hit clear and enter. Go over to L2 and hit clear and enter. Now, guys, if we ever come in here and L1 and L2 are not there, you can push stat and go to number 5. It says setup editor and hit enter, and it'll make them come back, okay? Just so you know, because some people delete them out. So let's put our x values in first. Let's see, I've got 15, enter, 8, enter, 31, and so on. Make sure everyone's putting this into their calculator. So let's see, that's 10 values, put in 1, 2, 3, 4, 5, 6. So we got all 10 in there. I'm going to shift over to my L2. I'm going to put 40, 100, and I'm going to keep entering all those in. So guys, make sure you're entering them in. So there we go. Now real quick, if we go back to graph, guys, we're going to push zoom 9 again. It kind of shows you the scatter plot, and here's what it looks like, okay? So you might be able to tell right there, it's kind of hard to tell a positive or a negative correlation. They're kind of bouncing all around up there. But we can hit stat, right 4. I'm going to do that again, guys. Stat, right to calculate, number 4, and hit enter and get all my information. So first it asks, is this data linear? Well, it's not. If I look over here, whoops, my R value is not 1 or negative 1, so it's not linear. But we do have an equation of best fit. So I'm going to write y equals, my A value is negative 1.3545, x. Then I have a B of plus 87.1568. Let's call that 1569. Let's just round it. So there's my equation. Now, we can find the slope from that pretty easy. It's what's in front of x, negative 1.3546. We'll just call that 46, guys. Let's round up. So I'm going to erase that for you. So I'm going to put 3546x. Rounding is not going to kill you here, though, guys. We should be pretty close. And then the y-intercept is positive 87.1569. Now, it kind of has a tricky question down here. It says, what does the y-intercept mean? If we're talking about the y-intercept, that means when x equals 0. And since x is the number of hours, that means we're talking about how much your score on your quiz is if we watch no TV. So I'm going to put the fixed score if no TV is watched. Okay? The fixed score if no TV is watched. When you're talking about the y-intercept, guys, think about what it's talking about when x is 0. Okay? That would mean 0 hours. So we watch no TV, this would be the score that you get. Okay? So let's go to the next part. We're almost done. It says if a student watched 20 hours of TV, what would be the best prediction of their score, of their quiz score? Well, guys, they're giving us an x value here. Okay? This is hours of TV, so we just need to plug it in for x. So I have y equals negative 1.3546 times 20 plus 87.1569. Now, there's a lot of decimals. Of course, I can put that right in my calculator. And so if you watch 20 hours of TV, this predicts that you'd watch about, or you'd make about a 60 on the quiz. Okay? The next one's backwards. It says if they made a 70 on their quiz. So that's a y value. So I'm going to have 70 equals my equation. Negative 1.3546 x plus 87.1569. Now I just need to solve this for x, guys, and we're finished. So I subtract the 87.1569 from both sides. And I know these decimals aren't fun, guys, but it doesn't exactly make it difficult. I got negative 17.1569 equals negative 1.3546x. I'm getting kind of tired of saying all these decimals. Then the last step would be to divide by this number. And we end up getting that x equals, I think it's 12.66. We're going to round that to about 13 hours. So, guys, on your quiz tomorrow, you're going to have a question that looks exactly like one of these, okay? It's going to give you a table. It's going to be a smaller table than the one you're looking at up here. That's going to ask you for the equation. Then it's going to ask you 2 questions. You're going to plug in for x or y. So we'll talk about it just for a second tomorrow before we take the quiz, but you need to get your homework done. We've entered these tables into our calculator before. It's just today we're not going to get -1 for R or 1 for R, and we may have lots of decimals, okay? If you go 4 decimal places, you should be good. If you have any questions, we can talk about it tomorrow. Good luck.